Hi, my name is Damir Murat and I work as an IT architect at a company called Croz. Croz is based in Zagreb, Croatia, but we also have an office in Belgrade, Serbia. One of the main areas of expertise at Croz is custom application development for our clients in finance and public sector, as well as in other large IT systems. Between other things, Croz is also a long-term Alfresco partner, and during last few years we have built quite a few successful projects based on Alfresco. As such, Alfresco is one of our strategic platforms for custom application development. This screencast is a follow-up for our Lightning Talk presentation that we held this year at Alfresco Summit in Barcelona. However, since that presentation was only a lightning talk limited to 5 minutes time, I will try to give you here some more details and in much slower pace about Alfresco and Neo4j integration that we've built. As you might know, Alfresco internals are actually pretty similar to a graph database. Alfresco concepts like nodes, metadata properties and associations can be directly mapped to a graph database building blocks like nodes, properties and relationships respectively. We thought that we could try to take advantage of this similarity and try to populate a graph database with Alfresco internal data representations. If we can manage to keep these two storages in sync, in the end, we should be able to execute native graph operations and maybe even enhance live Alfresco data, while original Alfresco data are kept intact. We thought that this may be pretty interesting. For many reasons, we decided to use Neo4j as our graph database of choice. It is the most popular graph database, it is very scalable, it has 10 years of successful usage in production, it is very well documented in constant improving process and development, and with a fantastic declarative query language called Cypher. For us, Cypher was probably a single most important reason to choose Neo4j. We believe that successful Alfresco Neo4j integration can bring us new set of features in our Alfresco development, which were not possible before. This includes a possibility to enhance Alfresco data by introducing new ad hoc nodes, properties and relationships, which are now not anymore constrained with Alfresco internal model. Then we may add properties and relationships, since this feature is not directly supported in Alfresco, and we can enjoy advantages of using graph operations of Alfresco data. And of course, we can use Cypher for declarative querying and easy exploration of Alfresco data, which we believe is much more simpler, clearer and powerful than using internal Alfresco APIs. With all this in mind, we finally decided to give it a try. We took one of our projects built with XJS, Grails and Alfresco technologies and decided to use it as a starting point for implementing Alfresco Neo4j integration. The original project's business case was from the insurance domain, where we built a customized document management solution for an insurance company with many branches. Primary business goal was to store and effectively access and manage documentation produced as a result of reported damages over goods covered with company's insurance policies. Documentation might include pictures of damages, various text documents in primarily Office and PDF formats or scanned, and all this needs to be classified according to a custom scheme before uploading to Alfresco. Although application supports any kind of damage, in our later demos we'll use only car pictures to keep things fun and simple. So, we've created custom Alfresco model for supported document types, Alfresco extensions to support business case requirements, and nice XJS Grails frontend for end users to use. We saw this project as the appropriate business case for piloting Alfresco Neo4j integration, since we believed it can bring some additional business benefits like, for example, easy visual analyzing which branch have many damages reported, or which kind of documents are dominant, etc. We are aware that these features can be built probably with Alfresco alone, but we needed something simple and understandable to start. Additionally, we decided early that our main focus will be on generic graph visualizations, which are not technically tied too much to the selected business case. Here is architecture of our proof of concept application. If we for a moment forget about parts related to the graph and Neo4j integration, we are actually looking at our standard architecture for building XJS, Grails, Alfresco solutions. On the front end, we have a framework which simplifies the creation of attractive data-centered applications based on Grails and XJS platforms. When we don't need document management features, that part alone is more than capable enough for building full applications, which should really not be a surprise considering technologies on which it is based. In that part, we develop features like customizable initial application generator, custom and enhanced XJS components, integrated JavaScript IOC container, automatic XSS and CSRF protections, flexible and stylish end-user notifications, then pretty advanced functionality for form and request validations, where constraints are maintained on Grails side and generated on the fly in JavaScript on XJS side. Then we have simplified implementation of AJAX communications, customizable and simplified error handling, built-in scanning support, module for maintaining database registries, and more. Among these functionalities is also our custom Grails proxy for Alfresco requests, which validates client requests by using Grails commands and makes sure that they are forwarded to the Alfresco in a secure manner. Requests are authenticated and authorized by Alfresco to ensure that user cannot access wrong data. On Alfresco side, there is also MVC extension, which enable us to use native Spring Framework concepts and components like controllers and services instead of using more involved classic Java web script approach. Let me quickly show you how with described building blocks we've implemented our original business case. You will notice that this part of application is not translated to the English. However, I will try to give you enough explanation so you can know what is going on. Here we have a tab related to management of documents. With documents we can do several things, like adding new one by using upload, multiple upload, or scanning. Then we can edit metadata related to the uploaded documents or see their history. If we, for example, try to upload a new document, we'll get a form which can display useful notifications about which data are required or maybe invalid. Notification is updated dynamically as we input data that will be submitted to the Grails application. This same constraints will be also validated again on the Grails side, possibly with several additional constraints, which is actually related to the concrete use case. There is another tab related to the management of pictures. As Its functionalities are pretty similar to the ones that I described related to the documents, but here we have enhanced a grid component which is able to display pictures as thumbnails of various sizes. There is also a search functionality where we can search by various criteria. For example, if I type in some word, I will get a document in which original file name for the document contains that word. We'll return back to this application later, but now we can go back to the high-level architecture to tell something more about graph integration parts. In Alfresco, we have developed an extension responsible for both initial import of Alfresco data in Neo4j and for keeping Alfresco Neo4j in real-time synchronization. For that later part, we use Alfresco behaviors mechanism, which listens for changes in any metadata and reports them to the Neo4j by using Spring Integration library. Spring Integration then forwards requests to the graph database by using Neo4j REST APIs to transfer pure Cypher queries or requests to our custom Neo4j extensions. And finally, on the front end, we have developed our generic graph visualization component based on D3 JavaScript library. Much more about these graph-related parts you will see shortly. Now, let me focus more on Alfresco Neo4j integration model. However, before we go in details, I will start next demo, since data procedure needs a time to finish. After last demo, I cleaned up both Neo4j and Alfresco databases so that we have a clean slate to start with. First, I will start Neo4j server. It will be up and running quickly. And as you can see here in web admin dashboard, Neo4j database is empty. We don't have any nodes, properties or relationships. Also, if you take a quick look in Neo4j browser, we'll see that Neo4j currently does not know about any node labels or relationship types. All of these will change very soon, or well, at least it should. Next, I will start Alfresco server from my development environment. Here you can see that Alfresco web archive or Alfresco war is deployed on Tomcat. I will start it up, and in console view we can see some log messages displayed. Near the end of Alfresco startup, initial import procedure will kick in, which you will be able to recognize by a bunch of green messages displayed. Alfresco web archive is actually a Maven project, which represents a fully functional Alfresco server. Beside all internal Alfresco models and dependencies, it also contains our custom extensions like Alfresco MVC model, DMS AMP model, or MIBI AMP model. All of these are deployed in Alfresco web archive and will be functional after startup. As we said, Alfresco database is empty, which means that it does not contain any custom application data, but rather only internal metadata required by Alfresco to operate. So, in this case, only this internal metadata will be imported to Neo4j. Later on we will add some documents and pictures to demonstrate how real-time synchronization works. Okay, here we have some green messages, and if we take a look at Neo4j dashboard, we will see that now we have some nodes and properties in a database. Okay, let's go back to the slides for a moment. And I will resize this windows so that you can see what is happening in the background. So, near the end of startup procedure, Alfresco checks if Neo4j is up and running. And when it is, Alfresco will ask Neo4j if initial import procedure is required or not. When Neo4j doesn't contain any Alfresco data, import procedure will start up. Current implementation of that last check is unrealistically simple, but it was good enough for us to keep going. There is also alternative initial import mechanism, which can be used in situations when Alfresco is up and running, and then we start Neo4j server with empty database. In such situation, user can send appropriate HTTP request to Neo4j simply by using browser, which will then trigger our custom Neo4j extension, which puts a dummy file in a configured directory from where Spring integration can pick it up and initiate initial import procedure. From that point on, both mechanisms use same logic for going forward. Initial import mechanism uses Alfresco internal node DEO class to acquire a list of all transactions that happened in some time period. From these transactions, it is possible to access all relevant node references and related associations, which should be imported in Neo4j. For each node in turn, Spring integration message is created and put in the appropriate channel to be picked up by our custom message processor service, which actually creates Neo4j nodes and relationships by using Neo4j REST APIs. Although using REST APIs for initial import is not best choice performance-wise, it was good enough for us and for our needs at the time. For a more realistic solution, we'll probably try to use some more serious infrastructure and more of Spring integration, maybe Spring batch machinery, or we may embed Neo4j under control of Grace application, or maybe turn to say Neo4j batch insertion, or most probably some combination of all of these. With initial import aside, Alfresco and Neo4j are kept in sync by using Alfresco behaviors mechanism. In a nutshell, behaviors are a set of listeners which are triggered for every internal change that happens in Alfresco. That is ideal hook for implementing synchronization between Alfresco and Neo4j. Once some of the listener is triggered, Spring integration message is created and put on the appropriate channel, from where it is picked up by same message processor service as during initial import phase. In the end, this results with Neo4j REST request, which updates Neo4j database. It seems that initial import procedure is done, and I can resize this Windows back. And we can quickly check the status of graph database. We can see that now we have a bunch of nodes, properties, and relationships. And we can see, hopefully, that Neo4j now recognizes some labels, some node labels, and relationship types. We can also quickly take a look at the state of Alfresco database by using Alfresco share application. We'll take a look in Alfresco repository, where we can see the database is almost empty and equal to the state which you will get after first installing new Alfresco server. There are only few empty application-specific folders which were created during startup as defined in one of our Alfresco extensions. So, here we have insurance company folder, which is root folder for our application, and all application-specific documents and pictures will be created underneath. If we take a look in application, in Graph Viewer tab, you can see insurance company node, which represents that application-specific Alfresco root folder you saw before. And in all graphs that you will see later on, this node will act as a root node. You can notice that insurance company node cannot be expanded, meaning it doesn't have a little plus sign indicating that it contains some children. And this should really be expected since we didn't add any documents or pictures yet. However, we will change this immediately. Okay, let's see now how real-time synchronization works. I'll resize this window again. And I'll clean up console view in my IDE so we can see any new messages. However, before going further, let's take a moment and look for at least approximate number of nodes and relationships currently stored in Neo4j. So we have around 820 nodes and around 840 relationships. Now, by using our application, I will add some documents and pictures. First, documents. With multiple upload functionality, I'll add some PDF files. Here I need to specify type and subtype for documents according to predefined scheme specified by our client. First the type, then subtype, and then I'll add and upload some files. At a few seconds, documents will be added to Alfresco, and in the background you can see some new green messages indicating that some new updates are sent to Neo4j. I will do the same with pictures, again by using multiple upload window. And first I will categorize images as police photos, and then we'll upload them to Alfresco. And you will see some more green messages scrolling. Pictures upload can require some more time than what is required for documents, since for every picture we are creating thumbnails in several sizes, and all of these are represented as new nodes in Alfresco and should be sent to Neo4j. Now, in the dashboard view, we can see again how many nodes we have. Now there are around 860 nodes and around 900 relationships. So apparently real-time synchronization works as expected. Okay, we can go now back to our application, to the Graph Viewer tab. I will execute a query which returns our root insurance company folder, and as you might notice now, it has a little plus sign which indicates that node has some children and it can be expanded by double click. As we are doing this for a few times, we will actually reveal Alfresco folder structure which was created when we uploaded documents previously. For example, here we have a year folder, then a branch folder, then folder which groups all damage reports, and finally a folder for a specific damage that we work with. When we expand that last node too, we'll get all documents and pictures that we have just uploaded. The same folder structure also exists in Alfresco, of course, as we can check quickly. Apart from importing only, let's say, normal nodes and relationships in Neo4j, we have also implemented a mapping which translates some interesting Alfresco node properties in standalone nodes in Neo4j. By enhancing original Alfresco data in that way, we can express and add explicitly some new meaning to the imported data, which might be significant for our business case. For example, we are translating document type and subtype properties into nodes in the graph database. Let me show you this. I will select all not expanded nodes and will then expand them with a single operation. Then, for better clarity, I will relay out the graph into concentric circles. Now you may see some new nodes representing types and subtypes of document and pictures, like for example photo type, then statement of witness type, legal basis type, or subtype police photo. With initial import and real-time synchronization behind us, there is one more component left to tell you something about, and it is our JavaScript visualization component. It is based on D3 JavaScript library and its support for scalable vector graphics, or SVG. As such, it works best in browsers with good SVG support, like in Google Chrome and latest versions of Opera. It also works nicely in Firefox, but is somewhat slower there. Component also works in Internet Explorer 10 and 11. However, in this browser, SVG rendering is not implemented in the same way as elsewhere, which results in something which is not so nice to see as in other browsers, but it still works. Earlier Internet Explorer versions do not have SVG rendering built in, so the graph component will not work directly there. But it should be possible to support SVG rendering in these browsers too, with some third-party library like, for example, SVG Web, which uses Flash for SVG rendering in browsers where it is not directly supported. We didn't try that though. Graph visualization component itself is currently implemented to work in XJS environment, but we have plans to refactor it in a pure JavaScript library so it can be usable in other JavaScript environments too. Additionally, component also depends on Neo4j cipher query language and on Neo4j labels, feature introduced in latest Neo4j 2.0 milestone releases. Neo4j labels are used for easy filtering of node types in cipher queries. Although cipher and labels helped us to develop more easily, they are actually only used during communications with Neo4j server, so we believe this can be extracted out, which should allow us to support other graph databases too. However, we don't have immediate plans to do it. But well, you never know. Otherwise, a graph visualization component is implemented in a generic way, and it is not dependent on a particular business case. This means it is not tied to Alfresco in any way, and it should be able to support visualizations for any kind of Neo4j graphs. In the graph visualization component, we've implemented quite a bit of features, like for example, interactive node expanding and collapsing, multiple layouts, including forced, hierarchical, and radial, visualization of multiple graph analysis algorithms, including degree in and out, closeness and betweenness, then hiding and filtering of nodes, multiple node selections, node groups and partial expansion for them, and so on. Now, I would like to show you some of these features in action. After the last demo, I populated the graph database by adding some more documents and pictures, so that we have a more elaborate graph to work with. Let's go first with some basic orientation. In the upper left corner, there is a pen and zoom control. On the right, there is a legend. And in the center, we have the graph itself. When you click on a node at the pane at the right, you can see a range of all node properties. When a node has an expandable indicator or plus sign, this means that node can be expanded, which you can do with double click. Now, when the node is fully expanded, plus sign is removed. When the graph is too large to fit in a screen, you can zoom it out by using a mouse roller, or if needed, to pan it a bit with mouse dragging. If this still doesn't help, you may try to change the layout. I will choose now, say, hierarchical layout, and expand some more nodes. When you double click on a node that is already expanded, it will collapse. A red color on relationships precisely indicates which relationships will be collapsed. When not expanded node contains more than two relationships, a little helper group node will pop up. It indicates a maximum number of relationships that can be expanded from it. You can expand them all with a double click. However, if you want to expand a node group only partially, you can do that by using right mouse click and expand specific relationships option. This will display a window where you can pick and choose what exactly you want to expand. You have already noticed that node labels are displayed in the graph and emphasized when you hover over a node. However, if you look more closely, when you hover over a relationship, you will also see a relationship type. When a node is selected, all nodes that are not directly connected with it are displayed as transparent. When you want to see all nodes in full colors again, you can cancel a selection with a click in the background. Multiple nodes can also be selected by using a mouse and control key, or with mouse dragging. Regarding selection, there are a few more options in a menu from where you can select all nodes. Then you can select only unselected nodes, which effectively does inversion of selection. And you can choose select unexpanded nodes, which can be very helpful when you want to expand many nodes at once. You already know hierarchical layout. However, in some situations, it can be impractical. If it doesn't fit, you can try with the radial layout. Or you can opt for default force-based layout. With force layout applied, um, all that nodes bouncing can be sometimes a little annoying. So when you want, you can fix a node position simply by moving it a bit. If you want to convert it back to default behavior, choose a float action from a menu. Now let's go back to radial layout for a moment. At the right pane, there is a Filters tab, which contains a grouped list of all property values for nodes displayed in a graph. With that list, you can select a set of properties which nodes should have to be displayed on the graph. For example, if we look for CMName property and corresponding group, we can filter out all nodes that does not have selected names. I will now expand all nodes. And we'll apply radial layout again. With this graph, we can take a look how graph analysis is working. Under Analysis menu, we have several options that implement various analysis algorithms. For example, if we apply out degree centrality, for our particular graph, we will see which damage folders have the most uploaded documents and pictures simply by looking at node sizes. On the other hand, if we apply in degree centrality, we will see which document types and subtypes are used the most. For example, we can see that our insurance company has stored more police photos than medical photos. In the same manner, we can apply the rest of our algorithms. When we don't want to have any analysis applied, we will select Reset option. And at the end of this demo, I will mention what you can do with that query combo at the upper left corner. In that combo, you can type in arbitrary sci-fi query and execute it against Neo4j database. Or you can choose one of already predefined queries. There is also a useful option which allows us to automatically apply desired layouts and analyze these algorithms on returned and displayed graph, like in this last example. Here we have hierarchical layout applied together with out degree centrality analysis algorithm. So, what can you do with all of this? Well, although we have some ideas, as you can see, we are not quite sure yet. However, we believe there are many possibilities and that our little proof of concept will find its place in future projects at Croz. If you have another idea of your own, please let us know. At the end, let me quickly mention some people behind this implementation. First of all, there is my young, brilliant and very hard-working colleague Matija Folnović. Then myself, Damir Murat, and finally our excellent project manager Ivan Krnić, who geared us in right direction, let us play with interesting technologies. There are also many other kind people at Croz who helped us to make all this either with technical insights or with very enthusiastic interest and support. So, if you like or don't like what you just saw, or you simply want to share some thoughts, you can contact us on these Twitter channels. Thank you for watching and your patience.